Hey everybody, Dr. Nelson here. This is a video about how to solve consecutive odd integer word problems. So what we're going to do is we're going to do a couple problems together. So the first couple pages, take notes with me, and then you'll have a chance to pause the video and try a problem on your own. And then at the end you can see how you did. Alright, so what do we mean by consecutive odd integers? Well, it says if you count by twos from any odd integer, you obtain consecutive odd integers. For example, 7, 9, 11 are consecutive odd integers. And this statement is true because if I add 2 to the 7, right? 7 plus 2 is 9. If I add 2 to the 9, 9 plus 2 gives you 11, and so on. If I wanted the next odd integer, I'd add 2 to it, right? And then make it 13, and then 15, and so on. So the same thing applies for negative integers. Let's say if I have, say, negative 27. Well, if I add 2 to the negative 27, I'll get negative 25. If I add 2 again, I'll get negative 23. If I add 2 again, I'll get negative 21. And this goes on forever. Alright? Now, what we're going to do is we're going to solve some word problems where they don't tell us, okay, what the first integer is. Like here we know it's 7, 9, 11. So the first one is going to be an unknown. So anytime that happens, you let the first integer be a variable. So we're going to use n. So n is going to be the first integer. Alright? Now, if you notice, if you see the pattern, all these consecutive odd integers increase by 2, right? So this increased by 2, and this increased by 2, and that's the pattern throughout. So the next integer, right, is going to be 2 more than n, so it's going to be n plus 2. All right, that makes sense? So again, that's going to be an odd integer. We don't know what it is, but it's odd. If I add 2 more to it, it'll be the next odd integer. And then if I add 2 more to that, right, so it's going to be n plus 4. That'll be the next consecutive odd, and then n plus 6, and then n plus 8, and this keeps on going forever and ever and ever. Alright? So, this right here, do me a favor, put a star right here. This is the key thing you gotta know to be able to solve consecutive even integer word problems. So let's try a couple problems. Why don't you turn the page, and take a look at this first one here. Alright? It says the sum of two consecutive odd integers is negative 80. What are the integers? Okay, so again, we know we have two integers. They're consecutive and they're odd, right? That add up to negative 80. And notice they don't give us the first one, right? So we're going to let n be the smallest odd integer. All right, that says integer right there. All right, and now because we don't know what the first one is, we know that the second one, right, is going to be 2 more than that, right? Because, again, consecutive odds increase by 2. So the second one is going to be n plus 2. That's going to be the next odd integer. And because we know that n is going to be the smallest, and n plus 2 is going to be the next one, we can add them together, and the sum is going to be negative 80, right? So let's write an equation for that. So it's going to be n, that's the first integer, plus, in parentheses, n plus 2, that's the second, and together they're going to add up to negative 80. And now what we're going to do is we can just solve the equation. So n plus n is 2n, plus 2 equals negative 80. I'm going to subtract 2 from both sides. And you got to be careful with your negatives here. Okay, so 2n equals negative 82. And then divide both sides by 2. It's a little messy, but you get the idea. And n is going to equal negative 41. Alright, so we're almost done here. So now that we know what n is, alright, we know that this n is now negative 41. So negative 41 is going to be the first integer. Alright, and that means the second one, or the next one, is going to be 2 more than that, right? So if I add 2 to negative 41, we get negative 39, right? And guess what? If I add negative 41 and negative 39, we get a sum of negative 80, so we know we did it right. Alright, let's do one more of these. Alright, this time it says the sum of 3 consecutive odd integers is 33. Determine the middle of the 3 integers. Alright, well this you really solve it the same way except for one additional part. Alright, so again, we're going to let n be the smallest. That means the next one, the next integer, is going to be 2 more than that, right? So that's going to be n plus 2. That'll be the next integer. And then finally, the largest is going to be 2 more than this. So it's going to be n plus 4. All right? And we know that the sum of all these expressions is going to equal 33. So let's write down that equation. It's going to be n plus 2, that's the second integer, plus n plus 4. All those together are going to add up to 33. All right, so now let's just simplify and solve. So I know we have 1, 2, 3 n's. So it's going to be 3n plus, let's add the constants. So 2 and 4 is 6. So 3n plus 6 equals 33. And then take away 6 from both sides. So we're subtracting the constant, right? So 3n equals 27. If I divide both sides by 3, we'll get n equals 9. All right? And the fact that that's an odd is a good thing, right? Because we're trying to figure out the sum of 3 consecutive odd integers. All right, finally, let's plug this in over here. So we know n is now going to be 9, right? So 9 is going to be the first integer. 9 plus 2 gives 11. That's the second integer. And then 9 plus 4 is 13. That's the third. And guess what? All these together add up to 33. So what I want you to do is I want you to pause the video and try the Your Turn Now problems. And when you're done, hit play. You can see how you did. All right, good luck. All right, welcome back. Let's say you did this practice problem. So the question says the sum of 3 consecutive odd integers is 129. What are the integers? All right, so again, they don't tell us what the first one is, right? So that first one should have been n. And then the next odd one is 2 more than this, right? So it's going to be n plus 2. And then the third one is going to be 2 more than this, so it's going to be n plus 4. And we know that the sum of these 3 integers is going to add up to 129. So our equation should have been n plus 2 plus n plus 4 equals 129. So now we can simplify and solve, right? So this is going to be n, and n. That should have been 3n. And 2 and 4 will be 6 equals 129. And then I'm going to take away 6 from both sides. And we get 3n equals 123. And then finally I'm going to divide both sides by 3. And we get n equals, that's going to be 41. All right? And now we know what n is. Well, n is going to be 41. And then 41 plus 2 is 43. And then 41 plus 4 is 45. And look at that. 41 plus 43 plus 45 does indeed add up to 129. So we know it's correct. All right. How'd you do?